Welcome to the series of smart homes and smart grids. All of us are seeing that everything around us are getting smarter. Say the cities, buildings, phones, people, and so do the energy sector as well. One of the key aspects that is gaining attention and also which is being experimented and implemented successfully is smart grids. So in this series, we may have a range of videos from real short video, which will be just a quick walkthroughs on smart grids to a deep dive on some topics which demand that. Well, we have been hearing about smart grid for a while, but not everyone knows what the grid is, let alone the smart grid. So the term grid refers to the electric grid, which is actually a network of transmission lines, substations, transformers, and also the one which delivers electricity from the actual source, that is the power plant, to your home or business location. And when we look at our history, India began utilizing grid management, that too on a regional basis, sometime during mid-1950s, that is 1960s. And they started with 5 regional grids, which are northern, eastern, western, northeastern, and southern grids. And since then, we have been actually going through lots of industrialization and urbanization, so which has led to a tremendous growth in the power grid as shown in this map. And at the same time, some locations do face deficit as well with increase in population. And currently, global energy sectors are in transition due to increasing concern over sustainability and climate change. And smart grids are one of the ways to going sustainable. So with this preamble, let's look how global energy departments are defining the smart grids. The Department of Energy US defines the smart grid as the electricity delivery system from point of generation to point of consumption, which is integrated with communications and information technology for enhanced grid operations, customer services, and environmental benefits. Whereas the European Technology Platform defines a smart grid as an electricity network that can intelligently integrate the actions of all users connected to it, generators, consumers, which actually efficiently delivers sustainable, economic, and secure electricity supply. So from the above definitions, it is evident that the smart grid program globally aims to achieve a continuous delivery of clean and affordable energy. So let's put the definition in simple terms. Smart grids are nothing but an electricity network which enables a two-way flow of data and electricity with the help of digital communications technology, enabling one to detect, react, and proact to changes in usage and multiple issues. So this leads to our next question of the necessity to move to smart meters from our conventional meters. All of us know that in a typical conventional meter, most of the electricity utilization of a consumer, it is being recorded by a traditional electromechanical meter or an electronic meter. It comes with digital display, and the bills are generated by utility personnel just by recording the usage for a specific period of time. Here in Tamil Nadu, it is bi-monthly. And this traditional process cannot monitor or control. So this leads to the smart meter, which is going to act as a super future for power industry because it serves as an interface between consumer and the utility company. Well, how does that happen? Because basically, this smart meter collects the data from the electrical appliances, it records and stores the data at regular intervals of time, establishing the two-way communication, that is between the utility and the consumer. And whatever data has recorded and stored, it will analyze the data, and based on analysis, it supports controlling. Since the data transfer happens between the consumer and utility in a timely manner, that is, it happens bidirectionally. As shown in this figure, both the parties have the advantage to plan and use the energy appropriately. Say, for consumers, it helps to utilize the energy efficiently and also importantly to reduce on wastage. At the same time, for the utility center, it helps for better monitoring and control. Also, you get to see the real-time pricing and automatic billing, outage detection, load scheduling, even identification of power theft, and it also avoids meter data tampering and ultimately providing better service. Importantly, we can see that government faced a huge revenue gaps of 13,591 crore in 2012 and 8,500 crore in 2016 here in Tamil Nadu, and I would be assuming that the trend continues even today. So this could be met out with the installation of smart meters. To wrap it up, migrating to smart meters have several advantages in all spheres for the society, environment, distribution company and consumers. So to the environment, it reduces losses and transmission in electricity. For the distribution company, it improves the billing service and revenue collection, and also it reduces the losses and also facilitates the demand side management. Whereas for consumers, like for us, we can track our consumption while we are using the appliances. So accordingly, we can plan our utility or usage, and also we can plan based on the peak and accordingly receive better quality of electricity. So with this, we close this session. Let's meet in the next session with the architecture of smart grid.